Hi everyone, welcome back to Geeks for Geeks practice. So today we'll be discussing the problem of the day for yesterday. That is Valentine sum. And if I'm audible to all of you and my screen is perfectly visible, then you can consider giving a +1 in the chat and like the video so that we can begin ahead with the session. Late. I'm not late. 3 p.m. right? So it's 3 p.m. and I am at on time. Okay, so I'll just wait for others to join, and then immediately after that we'll begin with the session. So how many of you have solved this problem? First of all, how many of you solved this problem yesterday, and did you try this problem, and did you face any difficulties with this problem? And if you tried this, so which approach did you try? Did you try? You tried a DFS or a BFS, and how did you implement this code? You can tell me about that. And okay, great. So if everything is perfect, so you can consider giving a like to the video if you haven't already. And with that, I'll just wait for 1 more minute for other people to join, and then after that immediately we'll begin. Okay, so this is an interesting problem, and it's a good problem on BFS, or you can say DFS, or in general binary trees. So I'll start with the problem within 30 seconds, just waiting for others to join so that they do not miss the problem statement. Okay, right. So shall I begin? If everything is perfect, so you can consider giving a +1 again, so that I should begin with this, right? Okay. Perfect. So let's begin with the problem statement. So the problem name, as you know, is Valentine sum, and it's a medium level problem, although the accuracy is high, because if someone is good with BFS and DFS, BFS or DFS, so he can easily submit this problem, and the submissions are very close to 2000. The points offered for this problem are 4. So it says that Cupid wants to strike maximum house maximum houses in Geekland on Valentine's Day. So Cupid wants to strike the maximum houses in Geekland on the Valentine's Day. The houses are arranged in the form of a binary tree. So you can see like this, it has been given. So this is a form of a house in Geekland, and Cupid is standing at the target node, right? So initially he's at the target node, or you can say the starting node, and you have to find the sum of all the nodes within the maximum distance k from the target node, right? And the target should be included in the sum, right? So this is the problem statement, right? And I'll repeat again. So the overall structure of the houses, it is overall all the houses are arranged in form of a binary tree, and apart from this there is a target node that has been given, target node or the initial node that has been given to us. And with that, what you have to do is you have to find the sum of all the nodes with which are within the distance less equal to k from that node. Okay, so is this much part clear to everyone? Is the problem statement clear to everyone? Is the problem statement clear to everyone? If the basic problem statement is clear to everyone, then please write a +1 or write a clear in the chat, so that I know that at least that much part is clear to everyone. Okay, right. So let's copy this test case that has been given to us, this first test case. Yeah, right. So I have just copied it. Okay, yeah, it's clear to you. That's great. So what you have to do is, let's say you have been given this 1, then from 1 to 2, then 2 to 9, 9, then 3, this 9, then 2 has a child 4, 4 has children 8 and 19, then 8 8 is having a child 30, 19 is having a child 40 and 50, and after that 9 is having child 5, and 9 is also having a child, that is 7, right? After that, if you see, 7 is having a child 20, and 7 is also having a child 11, right? So this is the initial that has been given to us, and the with this, the target node that has been given to us, this is the target node, right? This is the target node that has been given to us. So yeah, from this target node, right, this is the target node. Let's change the color of the pen. So we have been given this target pen, and not the target pen, target node, sorry. Yeah, target node. You have been given this target node, and you have to find the sum of all nodes which are at a distance which is lesser equal to k has been given in the problem. So let's say k is given to be less equal to 1, right? So for this 9 you have to find all the nodes, right? For this 9, for this particular 9, you have to find all the nodes which are lesser than equal to 1 distance from the target node, that is 9, right? So lesser than equal to 1. So how will we do this? So you can see that what can be the nodes. So node, this is one node, you have to include the target node, right? Then after this, 5 is at a distance of 1, right? 5 is at a distance of 1. 9 was itself there. Then you have 5 at a distance of 1, the left child, as the left child. Then you have 7, right? 7 is as a right child, and it is also present at a distance of 1. Then this node 20 and this node 11 is present at a distance of 2, and you will be taking distance lesser equal to 1 only. And you can see this node, this is the root node of the tree, and this node is 1, so you will also be including this node. The reason is because it is also at a distance of 1, although it is on the upper side, it is the parent of 9, but you will be including bottom as well, that is the children, as well as the ancestors or the parent, right? So this much part I hope is clear to everyone. So if this much part is clear, then what you can do is you can consider giving a +1 in the chat quite quickly, so that we can begin ahead with the further explanation. Okay, so you add these two up. So 9 plus 5 basically gives me a 14, then 14 plus 1 15, and 15 plus 7 total 22, right? So is this much part clear to everyone? If this much part is clear to everyone, then please consider giving a +1 in the chat. If this much part is clear to everyone, then please consider giving a +1 in the chat quickly. Is this much part clear to everyone? If this much part is clear to everyone, then please consider giving a +1 in the chat, so that we can begin ahead with the explanation of how to approach this problem, right? So is the test cases and the problem statement clear to everyone? Are the test cases and the problem statement clear to everyone? Like you can see, the answer is 22 for this case, right? Okay, so why 9 is target node? So it has been given, right? It has been given in the problem. You can see it has been given in the problem. You can see here. So target node is 9. It has been given in the problem itself, right? It has been given in the problem itself, and k is equal to 1. That means the distance that are lesser equal to 1. That node, you have to take the sum of all the nodes from this target node 9, which are at a distance lesser than equal to k. And here k is 1, so that is why distance lesser than equal to 1, right? Is this part clear to everyone? If this part is clear to everyone, then please like write a +1 in the chat, so that I can begin ahead with the explanation of the problem. Shall I move ahead with the explanation of this problem? I'll be waiting for your responses. So if this much part is clear to all of you, then please give a +1 in the chat. And if you haven't liked the video, so you can like the video, so that I know that everything up till now is clear to all of you, and we can begin ahead with the. Okay, Kunal is saying yes. What about others? Right. So this is what you have to do, right? Now that being said, let me do this, right? So let's say what you can do, right? Let's say what you can do. Okay, so let me erase this as well. This I'm just making some space for us to work upon. Okay, right. Let me do one thing. Let me just copy this tree and bring it down. Yeah, now we are good to go with this tree. 19. I guess I missed some part of the tree. 8 and 30. Then 8 is connected to 30 and 19 is having children, let's say 40 and 50. Okay. Let me just keep a bit up. Okay, I hope that it is visible to all of you. Let's move a bit down. Okay, perfect. Okay, right. So this much part is done. Let me complete the tree. So this is 5. Yeah, this is the tree that has been given to us. Now let's see what you can do. Right, first of all, first things first, you will notice that this is a binary tree, right? So since this is a binary tree, right? So let's say you know a target sum, right? You know target node, right? If you, even if you know a target node, then you cannot do much. Why? Because let's suppose that you know this is your target node, right? So you can go towards the down of this, towards the children of this no particular nodes, that is 5 and 7, and or lower, more down, deep down if it is required. But how will you find the upper nodes, right? The nodes which are ancestors and which are present at a distance which is less equal to k, right? There is two parts for this, right? What this is, what node at distance which is node at distance which is lesser equal to k, right? So there are two parts to it. There are children for that particular node, right? From target, let me write target, right? So child of 9 is missing, so I have written it. Okay, if you haven't liked the video, so you can consider liking the video, please. Okay, so if you will see, so you will have to calculate the childs, right? And you can easily know that which are the children which are at, you will first of all try to find this, the children which are lesser equal to k, which are at a distance which are lesser equal to k from the target node, right? Apart from this, there is the second thing that you want to find, and the second thing is the ancestor, or you can say parent, which are at a distance which is lesser equal to k, right? You, in a binary tree, you can, let's say you are at a current node, right? If you are at a current node, so what you can do is you can move towards its left child and you can move towards its right child as well. But how will you move towards up, that is towards the parents and the ancestors, right? So this part is done. The first part of the problem, there are two parts to calculate this, right? The first part is that you need to calculate the all the children sum which are at a distance which is lesser equal to k, right, from the target node. But you also need to calculate the sum of all the ancestors which are ancestor and the parent which is lesser equal to k, right? How will you do this? You can always, in a binary search tree, since this is not a bidirectional, right? Because you have been given a current node, and from that node you can only go towards the left or you can go towards the right. How will you go towards the up, right? How will you go up? How will you go up to the parent and the ancestors, right? So is this problem clear to everyone? Like, what is the question trying to ask you? What is this challenge in this question, right? This is the challenge. Like, this is not the challenge. This is not the challenge. The challenge is this part, this second part. Is everyone clear with this? If everyone is clear, then please write clear or a +1 in the chat so that I can begin ahead with the problem. Okay, is this much part clear to everyone? I'm waiting for your replies, then only I'll begin ahead. I'll move ahead with the further solution. So is this much part clear to everyone? Is this much part clear to everyone, that the challenge is not that you need to find the children which are lesser equal to k distance away? That is not the challenge. The challenge is that you need to find all the ancestor and the parent which is greater, which are which are up on the upper side, right, on the top, which are your ancestors and parents that are at a distance lesser equal to k, right? This is the challenge behind this. Now let's try and think what we can do. Okay, so I'll be erasing this much part because I hope that this much part is clear to everyone, right? So now let's move to further explanation, right? What we actually need to do from here on. So just let me make some space for us, right? So now the challenge lies ahead, right? So what I'll be doing is I'll be running a breadth first search. I'll be running a breadth first search, or you can also run a depth first search, but for the sake of simplicity, let's see a breadth first search. What I will do is I'll run a breadth first search from the root of the tree, and I'll make a parent, right? I'll make a map which will be storing the parent for all the nodes, right? So the what I'll do is I'll make a parent, you can say map, which will be storing like parent of 1. Parent of 1 is what? Parent of the root is, it is nothing but null, right? There is no parent for the root. Okay, what is the parent? What is the parent for 9? The parent for 9 is nothing but what? It is nothing but 1, right? What is the parent for 2? The parent for 2 is nothing but 1, right? So in this way you can also go up, right? Once you, let's say you are at this, right? So for this one, you can, how will you go up? Or let's say, let me try to say this. Okay, let's say parent of 4 is 2, right? And parent of 8, let me rewrite it again, sorry for my writing. Parent, yeah, right, parent of 8 is what? Parent of 8 is 4, right? And parent of 30 is 8. So let's say you are at this 30. So from this 30, how will you go up? So you'll search for the parent. You will from the unordered map, why unordered map? Because it will be order of n, right? Unordered map, or you can say hash map in Java. From the unordered map you can easily get from this 30 to this 8, right? Because this 30, if you'll ask for its parent, so it will give you 8. In this way you can go up. For this 8, how will you go up? So for this 8, if you will try to find the parent of 8, so you'll go to this 4, right? And for this 4, how will you go up? So you will try to find its parent. So its parent in the map will be stored as 2, right? So you'll go up again, right? And for this 2, how will you find its parent? How will you go up the ladder? How will you go up the binary tree? So you will again ask for its parent, and you will get a 1. Now again, from, if you want to go up, so you'll ask for parent of 1, and it will be null, right? So in this way, whatever is the level up that you want to go, upwards on the binary tree you want to go, you can do it, right? So is this part clear to everyone? Like, why am I storing the parents? Is this much part clear to everyone? Only then I can consider moving ahead, right? Is this much part clear to everyone? Only then I can consider moving ahead. If this much part is clear, please write a +1, or please write a clear in the chat. Also, if you have joined the stream and you haven't liked the video, so you can consider liking the video, okay? So that it can reach as many people as possible, because we are trying to provide quality content to all of you, right? So is this much part clear to everyone? Is this much part clear to everyone? Please give a +1 or clear in the chat. And if you haven't liked the video, so you can consider liking the video, okay? Right, so is this much part clear to everyone? Perfect. So now that being said, what will you do next? That is the part, right? What will you do next, or how will you approach the question further? That is the task. So what you will do is, basically, you will be, first of all, you will run a BFS to find the to get the parent, right? To store the parent for all nodes, right? Parent for all nodes, right? This is what you will do. first of all you will be doing this, right? After this, what you will do after this, you will be running a BFS again. Why you will be running a BFS? The first BFS you will be running to find the parent of all the nodes, right? Also notice one more thing, that the target node that will be given to you, you will be only given the value of the target node, you will not be given the position of the target node. So that is why from this BFS as well you will find the position or the reference, you will find the reference for the target node as well from a BFS function that you will be running to find this position of this 9 or the target node, because only the value 9 has been given. You don't know where in the tree this target node is, right? And if you don't know, so how will you run a BFS, right? So this is a different kind of BFS. Why this is a bit different? This is a bit different because in this BFS what you will be doing, you will be exactly working like that. You will be having a level, the level which will be initially initialized to 0, and your sum will be initially equal to the target. Okay, initialize your sum to target. After that, what you will do, you will simply push your current in the queue, and you will need to do one thing, and that is that you can have a visited array, or you can have something like that, an ordered set, or set, or any data structure for marking that whether a particular node has been visited or not, right? So this is why you need to have target and all these. I hope that this much basic BFS you all know. After this, what you will do is, first of all you will try to find for this 9. You first of all you will be going to the left and the right? 9 plus 5 plus 7, you will be going down. You know how will you be going down, but how will you be going up, that is also now clear, right? How will you go up to, how will you go up? So you will go up, like let's say first of all at the level 0 there is only 9, right? And at the level 1, let's say at the level 1, who are the nodes at the level 1? So the level 1 nodes are 1, 5 and 7, right? How do you get this 7? So this is the right child, 5 is the left child, and 1 is what? 1 is your parent, right? Or ancestor, right? After that, or sometimes it will be sibling as well. So I hope that you can consider this. What is the level 2? So let's say level 2 is nothing but this 2, this 20, this 21 and this 11. So at every iteration you will be checking the level. So you in your BFS, what you will be doing is, besides checking that, besides running the BFS until and unless your queue is empty, besides doing that, like you do this, right? Not of queue dot empty, unless and until the queue is empty you will keep on running. Also you need to do one thing, that you need to keep a check that level is lesser equal to k, only then you will be running your BFS. Okay, and in this all the part will be similar, right? You will be checking it for the right child. If the right child exists, then you will be running you'll be pushing it into the queue, and you'll be marking it in a set or a visited array. Then you will be storing the right child, left child if it is available or it is not null, right? And once you do that, so what will you do after that words? So you'll push it into the queue and you'll mark it as visited, and then you will also do for the ancestors, or you can say the parent or the sibling, right? So now I hope that you know that you can always move down, right? You can always move down, but how do you move up, or how do you check for the siblings, right? So now you know how do you check it, right? You can make a parent array or previous array. What is the node prior to that, that can be previous of it, right? So in this way you can do this, right? Is this much part clear to everyone? दो भी होगा distance में, 2 भी होगा distance में, just let me see. 2 is not there in the distance. If the value of k is 1, then the answer will be 9 plus 5 plus 7 and plus 1, which will eventually give me a 22, right? So for this, the k is the target node is 9 and k is 1. And how do I did it? So I ran a BFS for the left child, right child and the ancestor, right? So this is how I tried to do. Now let me show you my code part for this. Also one more thing, since we are running a BFS, since we'll be running a BFS, okay, so the time complexity for this code will be nothing but order of n, right? Because I am assuming that you use a visited array or a visited map or things like that. It will be order of n only, because there is no use of adding any extra log n factor to this, right? After this, the space complexity for this code will also be order of n. Why? Because you are storing the parent, right? You are storing the parent, and then you are k is equal to 2, k is equal to 2 in k is equal to 2, k I was saying that let's suppose that k is equal to 2. Okay, in this question k value is only 1, right? So that is why you will check for k is equal to 0 and k is equal to 1. So k is equal to 0, but it's nothing but that the target node, right? And k is equal to 1 will be what? The left child, right child, and the ancestors, right? Left child, right child, and the ancestor, right? So I hope that this part is clear to you, right? So if this much part, I can see a lot of people are watching, so you can consider giving a +1 in the chat if this much part is clear to everyone. Okay, if this much part is clear, 2 भी होगा distance में, no 9 plus 5 plus 7 plus 1. Why? Because you will be checking for only the first level, and after that you don't need to check because k is only 1, right? So 1, then you take this one, this 5 and this 7, and you add them up along with the target and you get 22 answer, right? So okay, what I was saying, so I was telling you about the space complexity, right? So the space complexity will be order of n because you are using a parent map for mapping the parent with the children, right? So is this much part clear to everyone? Is this much part, I can see a lot of people are watching, you can consider giving a +1 in the chat because I've tried to explain it as best as I could. Now let us move to the code part. Is this much part clear to everyone? If this much part is clear, then please give a +1 or write clear in the chat. Okay, clear ++ you can also write that. And if you haven't liked the video, so please like the video because now I'll be moving to the code part. Before moving to the code part, let me show you that my code part, code implementation is working, right? Okay, let me show you my code implementation. So you can see that my code is getting accepted, right? After this, now let me show you my implementation for this, like how I have actually implemented this, right? So what you have been given is, you have been initially given the root node and you have been given the target and you have been given the k, right? After this, you have been given the what you will be trying to find is, you have been given the target, you have been only given the target, so that is the value, you have been only given the number, you have been not given the reference for that target, right? Reference, or where is the exact position of that target value, the target or the starting point, right? So for this you will be make a parent function. In this we'll be finding the parent of the every node, as well as we'll be getting the reference or the position of the target node in our tree, right? If there is no target, if actually there is no reference present for the target node, so that means that the target node is actually absent, so in that case the sum will be 0, right? And now let me show you like how this parent function is working. So this parent function, how it works is basically, first of all I make a node t. If the root is given, if the root current node is null, so in that case I'll return t. Otherwise in the unordered map, what I will do is, in the unordered map I'll mark the, for the root I'll mark it as null, right? For the root I'll always mark it as null. After that I'll be simply running a bfs. I'll be simply running a, note that this is not a recursive function, this is a bfs function only. So I'll be running a bfs, and in that bfs what I'll be doing is, if the parent data is equal to the target data, then I'll be storing the reference for the target node, right? I'll be storing the position of the target node, and if the right child of it exists, if the right child of the current node, I can see a lot of people are watching, please give a +1 if everything is clear to you. Okay, you can consider giving a +1 and like the video also. So if the right child of that particular node is existing, current node, so in that case I'll be marking its parent, I'll, in the unordered map I'll be marking its parent, the parent of the right child, as p, right? And I'll be pushing it into my queue for the bfs. After that I'll also be, if the left child is existing, then in the unordered map I'll be marking its position as p, and after that I'll be pushing it into my queue, right? I'll be pushing it into my queue, the left child. After that I'll pop out the current node from the queue, and once I'm done with that, so I'll return t, that is the reference for the target node in the binary tree. Okay, why do I need to return a reference? As I said, because we'll be given only the target value and not the reference or the exact position of that target value. So how will you start a bfs without knowing a reference or the position of the target node, right? After that if there is no target node actually present, so in that case the sum will be 0. Otherwise you will be making a variable sum, you will be running a queue, and you can also take an unordered step or an unordered map, or you can make a visited array, anything as per your choice. And in that, what will be visited array or a map sort of visited array, okay, map based visited array, you will be storing what, you will be storing the, first of all, the target, you will be pushing the target node into it, and you will be inserting it into the set or the map, you can say. for the sake that you do not repeat it, right? You do not end up repeating it in your BFS. Then you will be marking your initial level as 0. I can see a lot of people are watching. You can consider giving a like if you haven't already, please. Okay. What I'll be doing is, if my queue is not empty and my level is lesser equal to k, right, then I will check the size of the current level, right? I'll check the size, whatever will be the size, so that number of times I'll be running for this particular level, right? After that, what I'll be doing is, I'll be storing the current node in my f. You can take a current node or f or anything of your choice. I'll be storing my current node from in the front of the queue, and after that I'll store the sum of that particular node. Once I'm done with that, so I'll check if the right child exists and it is not already visited. So in that case, I'll push it into my queue, and after that I'll insert into my map or set anything, right? After that, I'll check that if the right child is present. If the right child is present, it is not. If the left child is present and it is not null, so I will check that if it has not been visited also. So in that case, I'll be pushing it into my queue and I'll be marking it as visited. After that, what I will do is I will check that whether the current node that is there, whether its parent is existing or not, right? Whether its parent is existing or not. So it will come from unordered map of f. That is the unordered map of current will tell me about the parent. So if parent exists, so in that case I'll check that whether it has been visited or not. If it has not been visited yet in the BFS, so in that case, what I will do is I'll simply push it into my queue and I'll mark it as visited. After that, I'll be doing this, that is queue.push, simply because I want to queue.pop, because I want to pop out the current node, right? After this, once this looping is over for the current level, so I'll increase the level, that is I'll level up, I'll increase the level by 1, and I'll always keep on checking in the while condition that while level is lesser equal to 1, lesser equal to k, and after that I'll return the sum, right? Is this code clear to everyone? Is the code, is the explanation part, is the intuition, everything clear to everyone? Everything is clear to everyone? If everything is clear, then please consider giving a +1, or you can write understood in the chat. Please write understood in the chat. And if you haven't liked the video, you can like the video. If you have understood this problem from the depth, the intuition, the code part, everything is clear to all of you, the time complexity, place complexity, if everything is clear, please write a +1 in the chat. Please write clear plus plus or +1 in the chat, and please hit the like button if you haven't already. Okay, does anyone have any doubt, or everything is clear? If it is clear, then please write clear or +1 in the chat. If you have any doubts still, so you can ask that, but I hope that everything is clear, right? What about it? Is everything clear? I hope that everything is crystal clear, right? The way I have explained this problem, I hope that everything is clear to all of you, right? Right, everything is clear, right? Why do you run a BFS, and how do you run a BFS? How do you check for the, how do you go back up? So for that, you make an unordered map, right? You make an unordered map and you store the parent of the nodes, right? So this is what we did for this problem. Is this much part clear to everyone? Please give a +1 in the chat if everything is clear. Okay, if someone new has joined, so you can consider liking the video also. Okay, so is this much part clear to everyone? I hope that it is actually. Okay, so if anyone has got any doubt, so you can ask it in the comments. Otherwise, if everything is clear, so please write clear in the chat. Okay, I'll be waiting for 1 more minute. If everything is clear to all of you, then you can write a +1 in the chat. Okay. Krishna Priya, I don't know what you are trying to say. Okay, so I'm just waiting for 30 seconds more. What you can do is, you can, if you like the explanation, you can hit the like button. You can subscribe the channel if you haven't already, because we bring more such DSA related content and problem solving content for all of you in C++ and other languages. Apart from this, make sure to solve the problem of the day for today, and also from tomorrow I'll be checking that how many problems you did, right? So you from tomorrow I'll be asking that how many problems you did in the previous day. Okay, so we'll be asking that in the comments. So that is it for today. If anyone has doubt, so they can ask. Okay, I'll reply back as soon as possible. Perfect. Thanks a lot for tuning